Hi friends, in this video we are going to talk about how the Earth works, specifically convection currents in the mantle. So you likely already learned about basic layers of the Earth, so this is going to be just a little bit of a review. The Earth is divided into a few main layers, and each layer has different chemical properties and different physical properties. First layer that you're standing on right now, is the crust. The crust contains the continents or land and the ocean floor. Then you have the mantle below the crust. The mantle is the thickest layer of the Earth and differs in physical properties throughout the entire mantle. The upper mantle is different than the middle of the mantle, which is different than the lower part of the mantle. And it has to do with the temperature and pressure differences at each point. Then you have below the mantle, you have the outer core, which is a very hot liquid under intense pressure. And then you have the inner core. The inner core is the hottest part of the inner planet, and it is solid. Another way to describe Earth's layers is by looking at its physical properties, and this is the one that we're going to focus on most as we talk about convection currents. The lithosphere is a layer of the Earth that is the rigid outermost layer of the Earth that contains both the crust, the continents and the land, or the continents and the ocean floor, and the rigid uppermost part of the mantle, aka the tectonic plates. Then you have the asthenosphere that's below the lithosphere. The asthenosphere is also a part of the mantle, but it's a softer plastic section of the upper mantle on which the tectonic plates and the lithosphere rests. By plastic, I mean that it sometimes behaves as a solid and sometimes behaves as a liquid, so it moves a little more easily than the mantle part of the lithosphere and the mesosphere below it, the rest of the mantle. Like I said, the mantle differs in chemical and physical properties throughout the entire thing. Now, the reason why we're talking about the asthenosphere and why that plastic physical property of the asthenosphere is really important is because of a method of heat transfer called convection. Convection happens in currents, it's a cycle, and it's a method of heat transfer that occurs in fluids, anything fluid, so liquids and gases, due to changes in temperature and density. When the fluid, the substance, heats up, when its temperature increases, that affects its density by making it less dense. And so the substance floats up, moves up. When the substance, the fluid, cools down, it becomes more dense and it sinks and replaces whatever the substance that moved away because it was more dense. So this happens every day. It doesn't just happen inside the Earth, but it actually happens in the atmosphere, and it happens in the ocean as well. And it's the same concept of the substance heating up, becoming less dense, and then cooling off and becoming more dense and sinking and replacing the material that moved up because it was less dense. And when there is a constant heat source, it creates a current or a cycle. We call them convection currents. Now we're talking about the Earth, and all that's needed for convection currents to occur is a substance that can flow and a constant heat source, like I said. Now that we're talking about the Earth, inside the Earth, the substance that flows, the fluid, is the liquid rock or magma of the mantle, and the inner core provides the constant heat source. So because we have both of those, heated magma within the mantle rises towards the plates, cools off near the crust, and then sinks back down towards the core. You notice here you have this convection current going right here. This means that convection currents in the mantle, the asthenosphere, cause the movement of tectonic plates in the lithosphere. Like a boat being carried away by water currents, Earth's crust moves with the currents of the mantle. So whatever's sitting on top, the lithosphere, whether it's land or ocean floor, it gets carried along for the ride, so to speak, based on the activity within the asthenosphere. And this is kind of like obviously an artist rendering, but you see the magma heating up, becoming less dense, sinking, becoming more dense, and whatever's on top of it being moved because of what's happening below it. And that's it. That's how convection currents work within the mantle, and they are what kickstart tectonic plate movement on Earth and create new landforms and geological events.